So, Chapter 11, Problem 9, returns and standard deviations. So, we have four states of the economy: boom, good, poor, and bust. Those probabilities of those states are 20%, 35%, 40%, and 5% respectively. So, what we have to do, answer the question: portfolio is invested in 30% each in A and C and 40% in B. So, what we have to do is calculate the expected returns for each state of the economy based on these weights, and then calculate the variance after we calculate the expected return for the portfolio. So, all right, so expected return for boom is going to be the 30%, so 0.3, that's this 30%, times 24. Again, I'm going to, piece of crap, use, 24%. I'm going to use whole numbers. Plus 0.4, that's a weight NB, times the 45%, plus 0.3 times 33, and that is 35.1%. So expected return in the good state, see, 0.3 times 9% plus 0.4 times 10% plus 0.3 times 15%. So just to make sure, so this is 0.3 times 0.4 plus 0.3 times, so basically I'm doing the exact same thing, adding all these up. 11.2%. So expected return in the poor state. So 0.3 times 3% plus 0.4 times a loss of 10% plus 0.3 times a loss of 5%. Multiply those and add them up, and we get negative 4.6%. And then expected return for bust, I'll use BU here, so 0.3, and that's a loss of, multiplied by a loss of 5%, 0.4 multiplied by a loss of 25%, plus 0.3 multiplied by a loss of 9%, and that is negative 14.2%. So our expected return on the portfolio, I'm going to use these four numbers to calculate our portfolio, and then I'm going to go to the next page. We'll use PO, so expected return on the portfolio. So we're going to use these, the states of the economy now. So we have a 20% probability of 35.1 plus a 35% probability of 11.2, and then a 40% probability of negative 4.6, plus a 5% probability, 0.05, multiplied by negative 14.2, and we get an expected return on our portfolio of 8.39%. So that is the answer to A. Now B, so calculate the variance and standard deviation. I'm going to go to a clean page. So this is problem 9 continued. So our variance for the portfolio, sigma squared p. So we got a 0.2 probability of 35.1%. We subtract that from, we subtract our mean from that, our expected return, 8.39%. We square it. And then we have a 35% probability of an 11.2% return. We subtract the expected return, the mean, square it, plus a 40% probability, that's the poor state, negative 4.6% return, minus 8.39%, square it. And then we've got the final one is 5% probability, 0.05 times the negative 14.2% minus 8.39. We square it, and that gives, you get 238.46. So so that's the variance over portfolio. So the standard deviation is just the square root of the variance, 238.46, and that is 15.44%. So we're looking at, we generally assume that we're looking at a normal distribution. So I think 68.5% of the observations should fall within one standard deviation. So so they should, let's see, 8.39 plus 15.44. That's like 0.8. So that's 23. That would be the upper limit of the standard. So, and then 8.39 minus 15.44. So we're going to rough it here. That's roughly 7, around negative 7, somewhere in that neighborhood. But anyway, so 68.5% of the observations should fall within that range. That's what the standard deviation is telling us.